Hello everyone, today we're going to look at using the central limit theorem. Remember that in order to use the CLT, the central limit theorem, we need to have samples, not individual values. So for our first example, women between the ages of 18 and 24 have an average systolic blood pressure in millimeters of mercury of 114.8 with sigma 13.1. Blood pressure follows a normal distribution. A. If one woman is randomly chosen, find the probability that her blood pressure is greater than 120. Since we're looking at a single woman, we're not using the central limit theorem, and we're just using the fact that blood pressure follows a normal distribution with mean 114.8 and sigma 13.1. So we want greater than 120, so this is a 1 minus situation in Excel. So 1 minus norm.dist. Remember 120 is x, 114.8 is mu, 13.1 is sigma, and 1 is the fact that I want it cumulative. If I do that, I should get 0.345703. Part B, if 30 women are randomly chosen, find the probability that their mean blood pressure is greater than 120. So now we have a sample. We have 30 women. So we're going to use the CLT for this. We still want greater than 120, so we're still going to need 1 minus norm.dist. And the only difference is our sigma. So remember, our sigma, our new sigma is, sigma, the sample size, is sigma over the square root of n. So 13.1 divided by root 30. Use the entire number. Don't find what 13.1 divided by root 30 is and then put the first 3 decimals. Use the entire thing. If we plug that into Excel, we should get 0.014846. So remember that when we're looking at the central limit theorem, our normal curve is getting skinnier. So if I'm looking for a tail, something greater than a number, and I'm looking at a skinnier version, the area is going to be a lot smaller. So it makes sense that this number is much smaller than this one. Remember, the skinnier the normal curve is, the less there's going to be on the tails. So as another example, let x be the distribution of IQ scores. Then x is normally distributed with mean 100 and standard deviation of 15. Find the probability that a randomly selected group of 100 people have an average IQ score above 110. So again, we have a sample of 100. So when I do the normal curve, we need to take that into consideration for our new sigma. So again, it's above 110, so we need 1 minus. And then the only difference is, again, the sigma divided by the square root of n. When I plug this into Excel, I get something that looks like this. Depending on how Excel is written, this might be an e and then negative 11. But that just means times 10 to the negative 11th. Scientific notation, you learned this way back in one of the first math classes. Remember that all this means is that I'm moving the decimal 11 places and I'm moving it to the left. I'm making the number smaller. So this is this number with 10 zeros before it. So it is a very, very, very small amount. And it's highly unlikely that we're going to have an average IQ score above 110 in a group of 100 people. And again, that's because our new distribution is very, very skinny. So to get over 110, it's a very small area. So for part B, it says find the probability of the average score being between 95 and 105. So this is still that the average score of the selected group of 100 people. We want between two scores, so we're going to need the difference of two of our normal distributions. And again, our new sigma is the 15 divided by square root of 100. Remember, the square root of 100 is 10, so 15 divided by 10 is just 1.5. So that's not a typo. It's not supposed to be 15. It is 1.5. And if we plug that into Excel, we get 0.999141188. And again, just as a reminder, as n goes up, sigma goes down. So the values are getting squished. We have a skinnier picture, and they're getting closer and closer to mu. So as another example, the grades on a certain test, we'll call it X, had an average of 78 and a standard deviation of 12. We're going to assume that it's normally distributed, and we're going to find the following, assuming we take samples of size 25. So the probability that X bar is less than or equal to 79. Less than or equal to means just norm.dist. The fact that it's the average is less than or equal to 79, we're going to take our 12 and divide it by the square root of 25, and the square root of 25 is 5. So that's why we have 12 divided by 5 here. Plug that into Excel and I get 0.661539. B says the probability that X bar is greater than or equal to 70. Greater than or equal to means 1 minus norm. So we have 1 minus norm.dist, 70, 78, again 12 divided by 5, and then 1. And that gives us 0.999571. C, the probability that X bar is between 68 and 80. If we've got the probability of between two numbers, that's going to be a subtraction of normal probabilities. So we have the norm.dist of 80, 78, 12 over 5, comma 1, minus norm.dist of 68, 78, 12 over 5, comma 1. Plugging that into Excel, we should get 0.797656. And then the last one, the probability that X bar is greater than or equal to 78. I don't even really need to use Excel for this because my 78 matches my mean. And remember that if you have something that's normally distributed, the mean is equal to the median. So if I have the median, by definition, that means half or below, half or above. So I should be getting 0.5. And I don't even really need Excel, but I can plug it in if I'm not thinking straight and don't realize that the number I'm looking at is the median. But you should get 0.5. For our last example, we have a certain group of college students read, on average, 10 books a year with sigma equal to 2. Let X bar be the average number of books read in a sample of 36 students. Our first question is find the probability that X bar is greater than or equal to 9. Greater than or equal to means we're going to have 1 minus the normal distribution, and our sigma, so our sigma of the sample, is 2 divided by root 36, which is 2 over 6, which is 1 over 3. So for our sigma, we're going to be using a third. And if we plug that into Excel, we get 0.99865. B says the probability that X bar is less than or equal to 10.5. Less than or equal just means the straight up norm.dist function. And again, our sigma is 1/3 this time. And plugging that in, we should get 0.933193. Our last case is the probability that X bar is between 9.8 and 10.8. And again, if you're looking at looking at numbers between two numbers, then we have subtraction. So we have the norm.dist with the 10.8 minus the norm.dist with the 9.8. And we get that our answer should be 0.717549. So read through the book, try some of the homework problems, and let me know if you have any questions. Good luck.